Well, hello, scrappers. Mike here. Welcome back to my channel. Today we are gonna start working on some RAM chips. All right, I've got some RAM chips here, like you would get off of computer memory RAM sticks. I saw a deal on these, and I bought them from a guy. So we're gonna process them, see if we can get some gold out of them. We're also gonna see if there's any silver in them. Sometimes there's silver, sometimes there's not. But I'm not going to treat them just like generic IC chips, okay? Now, if I only had a few of these, I would just put them in with my regular generic IC process, plastic IC process. I would run them through the delegging, incinerate them, and whatnot. If I only had a few, but I have a lot. I have about 2.5 pounds here. I have to get the scale out, and we'll verify just how much I have. But yeah, but since I've got a lot of essentially the same kind of chips here, I'm going to try and work out the most efficient way to process these chips. First off, I think we need to look and see what we're dealing with here, okay? They're all pretty much the same thing, they look like. I mean, I'm sure they're probably from different manufacturers and different capacities, but the packaging's pretty much the same. But let's see what we're dealing with. They're so nice and thin, you can just bust them right in half like that, easily. Let me get my loop out, and we'll take a look at the inside and see what we can see on the inside. My lighted loop, it's a little dark today, kind of cloudy, so turn the light on. And we'll have a look. And, well, I see the ends of gold bond wires, which is a beautiful thing. There's a lot of metal inside these chips. All right. Not just the gold bond wires. There's a lot of other metal in there. If you look at how IC chips are constructed, they're constructed on a framework, basically, that holds the legs. And if I was to run these through my delegging process, it would take these tiny, tiny little legs on the outside off. I'll try to get you a close-up look at some of these chips. Yeah, here's the chips we're working with today. They've got tiny, tiny little legs on them. Most of the metal, I think, is on the inside, so delegging them really isn't going to help us much. But it wouldn't do anything for all the metal on the inside, and I think 90% of the metal in these is on the inside, so I don't think we're going to bother running these through the delegging process. I think it's a waste of time. I don't think it's really going to help us much. So we won't bother with delegging. So let me get all these chips back in the bag. We'll weigh them up and see just how much we're dealing with here. I know there's at least some gold bond wires in there. There may be some gold brazing, and there may be some silver to be had too, so we'll find out here. Let's see. 1,208 grams, plus a little bit for the bag, or 2 pounds, 10.6 ounces. So that's what we've got to deal with today. So what I would like to do, rather than going all in on these, is maybe do a small scale test and see exactly what we're dealing with inside these, how much metal's in them, and maybe even we can figure out if there's any silver to be had in them. If there is, that may be a determining factor on just how we process these down the road. If there is silver, we'll do it one way. If there's no silver, we'll do it a different way. So let me see if I can get set up to do a small test on just a few of these and see what they look like after I get rid of the plastic outer coating. So what I've got here is just a grungy old crucible I've used for various experiments in the past. And I'm going to put some chips in it. And we're going to burn these chips with this MAP gas torch here and see what remains after we burn away the plastic. Have a look at what the internal structure looks like on these. Just how much metal is there and what kind of metal it is. Probably put these in some nitric acid and dissolve the metal that's left. And then we'll test that nitric acid for silver. See if there's any silver there.
cool. Fire, 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 fire.
Get all the organics burned off here. Sure, there's nothing left in here but ashes and metal. The flames have stopped, the smoke has stopped, so that's a good sign. This is how I would like the chips to look after I incinerate them. Nice and white and oxidized. All right. So we'll let this stuff cool down now. And we'll break them up and have a look at what's inside. All right, it's been a few minutes. This stuff's had a chance to cool off a little bit. The crucible's still quite warm, but my gloves on, so I'll get these into here. And let's see what we're dealing with here once I break them up a little bit. I'm going to try not to crush them too bad. I'd like to get a look at what's inside here, but, well, they're falling apart pretty good. I'll give you a close-up look here before I grind them up too much. The silicon dies are actually much bigger than I was expecting. They seem to take up a large portion of the inside of the chip. And maybe there's not quite as much metal inside these things as I was thinking there was. I'll give you a close-up look. Yeah, so here's what I'm seeing. So these part right here, this is the silicon die. You can see part of the metal framework down here. It's still got a lot of ash attached to it. On this scale, the gold bond wires are pretty hard to see. But they're in here somewhere. There, you can see, as I break that one up, you can see the metal. I hope you can see it. I can see it because of the reflections, but feel that metal in there? So that's the little framework that the die was attached to. So, let me grind this stuff up into a fine powder, and we will process it and see what we get. Okay, so it's sort of a good news situation. There's not nearly as much metal on the inside of these chips as I thought. I was expecting a much larger metal framework in there. I mean, don't get me wrong. There's some metal in there. What I'm doing now is I'm going to try and grind these up into a fine powder. Or at least as fine as I can without getting too crazy about it. In fact, let me pull a piece of metal out that I see in there. And grab it and show it to you here. See that? That's the framework that the die was attached to. And look at that with my loop. Is that gold plated? Sometimes the frameworks are gold plated. There might be some gold plating on that. It's really hard to tell. Now that it's all blackened, there might be some gold plating on it. Now let me check something else. Which I probably should have checked earlier. Oh yeah, there's a lot of steel there. Okay, look at that. There is a lot of steel there. But it's interesting. I can't find it again. That framework piece didn't seem to be attracted to the magnet. So we've got a lot of metal in here. Some of it may or may not be gold plated. I know we've got gold bond wires in here. A lot of the metal is steel. There's that framework piece again, or another one. No, it doesn't stick. So that may be something besides steel. So here's what I propose to do. After I get this stuff ground up a little better, I'm going to put it in this beaker. And we're going to treat it with some dilute nitric acid. And we will see what this looks like after treatment. We'll test it liquid and see if there's any silver in it, because that non-magnetic metal is possibly silver. And I know the gold's going to be in there. On this small sample, we're not going to get much. So this sample is mainly to find out, well, I wanted to see how much metal's in there, what kind of metal it was, and we'll find out if there's any silver. And then once we know all that, we can move on from there to process the whole big bag of stuff over here. Okay? So let me get this in the fume hood and get some acid on it. All right, got it in the fume hood. Let me put a little bit of distilled water on it. Get everything good and wet. Distilled water. Wash it down with some distilled water. All right. I'm going to put a little splash of nitric acid in there. Not much, just a little bit, a little splash. Yes, splash. Well, maybe two little splashes. Splash is an official scientific measurement. Also works in the kitchen. All right. Yeah, we've already got a reaction going on. I hope that bubbling is showing up. We put a little heat to it, speed things up, and we'll just let this cook for a little while. So after just a couple of minutes, we're starting to get some orange fumes in the beaker. I don't know if it's showing up on camera. I can just barely see it by eye. But we're definitely getting some orange fumes in there, some nitrogen dioxide production. So the nitric acid is starting to dissolve that metal away, because we got the bubbling and fizzing, and it's really not even hot yet. It hasn't had a chance to get hot yet. So we've definitely got a pretty good reaction going on, getting rid of that metal. I want to get it all into solution. I know there's iron in there in the form of steel, and that's going to be more reactive than any silver that might be there. So I'm going to have to make sure we get all of the iron in solution. Otherwise, the silver will just cement out on it, and it won't be in solution. And when we test it, we won't know if we actually have any silver there or not. So what I'll probably do is wait until this reaction comes to a conclusion, and then add a little bit more nitric to it, just to make sure I've got all of the metal in there in solution. Then we'll test the liquid for the presence of silver. See if we've got any in these chips. Okay, this has had a chance to warm up a little bit. The reaction's gotten a lot more vigorous. Maybe you can start to see the orange fumes in there better. It's getting quite dark to my eye, but for some reason it's not showing up on the camera viewfinder. But hey, it's coming along nicely. So we're just going to let this cook until the reaction stops, and then I'll add another squirt of nitric to it, and we'll see what we get. All right, this reaction seems to have died down to pretty much nothing, so let me put a little bit more nitric acid in here and see if we get any more reaction out of it, or if we've dissolved all the metal. Well, let that cook for a minute, but certainly right off the bat, it's looking like there's a whole lot of nothing going on. So I would say we have probably dissolved all the metal in there. So got all the steel dissolved. Yeah, a little bit of reaction maybe. All the steel should be dissolved. If there's any silver there, it should be dissolved. Yeah, there's a bit of a reaction. Maybe I'll just let this sit and cook for a little while longer. I was going to turn the heat off. But yeah, there's a bit of a reaction, so I'll just let this sit and cook for a while longer. Then I'll come out and turn the heat off. We'll let it cool off, and we'll let the solid settle. So hopefully we get a nice clear liquid on top, and we can test that for the presence of silver. That's my goal. So let it cook, turn the heat off, let it cool, and we'll test it for silver. All right, I've taken this stuff off the heat. It's had a chance to cool down. It's settled fairly quickly, which is nice. We've got a nice layer of very clear pale green liquid on top, so we should be able to run our tests now. So let me get this out of here and get it over on the bench, and we'll run a few tests on it, see if there's any silver in it. We will test for palladium too. I wouldn't expect there to be any gold in solution. The nitric acid should not have dissolved any gold, but nitric acid might have dissolved some palladium, so we'll test for that too. And depending on what we see in our tests, that will determine how we move forward with this batch of chips. Okay, let's run some tests on this stuff. First, let's see if there's any silver in here. So I'm going to put some distilled water in here. I could just use tap water, but the distilled water was closer, so I grabbed it. I'm going to add a little splash of muriatic acid to it, acidify it, put a lot of chloride ions in there. That should be more than enough. That's stirred up good. All right, so let's get a little of this clear green liquid from up on top off of here, and we'll put it in here, and whoa. All right, that's interesting. The green color got much more intense. You know, a few milliliters colored all this. But what I'm not seeing in here is any cloudiness. The liquid is still crystal clear. So I would say there is no silver, no detectable amount of silver in this stuff. Interesting the color change, though. I guess going from nitrate to chloride, one of the metal salts in there is changing color, getting much more intense in color. I don't know if we got nickel, maybe a little copper, hard to say. All right, so I would say there's no silver in there. That's going to be a determining factor in how we proceed with the rest of these chips. Let's see if there's any palladium here. So, do my usual white spoon method here. And we'll get a little stannous chloride on that. Freshly made just yesterday. And, well, initially the color got darker, but then it faded. So I would say there's no palladium or other precious metals in this stuff. Okay. So, what does all this tell us, and how do we want to move forward with the rest of this big bag of chips over here? Well, since there's no silver, I don't have to worry about processes that are going to lose silver. All right. If there was silver, what I would probably do is incinerate these, run them through a gravity separation to get rid of the bulk of the ashes, and then dissolve all the metal in nitric acid, like we did the small scale test, and then try to recover silver from it, as well as the gold and anything else good in here. But there's no silver, so I don't have to waste expensive nitric acid on dissolving all the metal in here. And that would take a fair amount of nitric acid. Nitric acid is a little expensive. All right, so what I will probably do instead is incinerate these, gravity separation, and then we'll use poor man's nitric, which is basically some nitrate salt, potassium nitrate, or sodium nitrate. I have a lot of sodium nitrate on hand. I can use that. And concentrated sulfuric acid. That will basically do the job of nitric acid at a fraction of the cost. And I don't have to worry about losing silver as silver sulfate because there doesn't seem to be any detectable amount of silver in here. So now we've got a path forward. We've got a plan on how to process these chips. So I think in the next video we will actually get started on that. And one last thing before we go, I'm going to gently agitate this liquid with the beaker at a good tilt like this. Let's see if we can see the gold in this beaker. The gold should eventually settle down to this bottom corner here if I do this, and we should be able to see it through the glass. So let me agitate it some, and then we'll take it out where the lighting's a little better and see if we can see any gold in there. Well, if I can get it to focus, which it doesn't seem to want to do, there's the gold in there. There's all those little gold bond wires down there. So even from this relatively small sample of chips, we got a fair amount of gold there. So I think we're going to get a lot of gold out of these chips when I process the bulk of them. So stay tuned for that. So I hope you found this video a little bit interesting, educational, informative, inspirational, whatever. Give it a like, give it a thumbs up, and subscribe to see that future video. There may be 1 or 2 videos out of processing these. And my other videos, I got a lot of other interesting gold recovery videos coming down the pike shortly, plus videos on other subjects. So subscribe to see those videos. And check out my second channel, Electric Geek 64, if you're at all interested in electronics or retro computing. There is more new content coming here in the very short order too. All right. Well, thanks for watching this video. I'll see you in the next one. Bye.